Hello and welcome to the Further Maths OCR Pure Core videos. This is Sequencing Series 1 Summing Series, and this is 1.4 using the standard formula to find combined sums. Okay, so if we have a more complicated looking sum like the one we have here, we can use the standard formula that we've already met in order to find the sums that are related to those. So if we start with this example, this can be rewritten into three separate sums. So it's going to be the sum from r equals 1 to 50 of r squared plus 3 times the sum from r equals 1 to 50 of r plus the sum from r equals 1 to 50 of 1. Do remember that that number at the end does need to be included because it doesn't just come out as a 1, it will come out here as a 50. So if we now use the standard formulas, we have 50 times 51, so n times n plus 1 times 2n plus 1 all over 6. That's using the standard formula for r squared. And then we're going to have 3 times the standard formula for r, which is 50 times 51 over 2. And then using the standard sum to n for 1, that's just going to be 50. Simplify these, add them all up, and we get 46,800. It's really important when you are doing these questions that you show that you are splitting it up like this. Write it out nice and clearly. It helps it be obvious what you've done, but it also helps you think very carefully about what it is that you are summing. Particularly as in later examples you'll see we do it in a general case and find an algebraic answer. It can be very, very difficult to get lost in the algebra if you've not set it out nice and clearly at the start. So as mentioned before, we may need to use these formulae to find combined sums in a general expression. Here we can see we're going up to n, not a specific number. So in exactly the same way, we need to split this sum up. So from r equals 1 to n of r squared plus 3 times the sum from r equals 1 to n of r plus the sum from r equals 1 to n of 1. And if we use the formula here, we have n plus 1, 2n plus 1 over 6 plus 3 n times n plus 1 over 2 plus n. So now we need to do some algebraic manipulation. I'm going to take out a common factor of n over 6, n plus 1, 2n plus 1, plus 9n plus 1, plus 6. And then when we simplify this further, we've got n over 6 times 2n squared plus 12n plus 16. So that's the same as n over 3, n squared plus 6n plus 8. And as always, if you can factorize, you should. Factorizing, we get n over 3 plus 2 n plus 4. And this is the general expression for this sum. Okay, so here is another example. Now here we've got a sum that doesn't start at r equals 1. We're starting at r equals 10. So what you need to do here, because all of our general formulas start from 1, we need to do it in terms of starting from 1. So what we're going to do is we're going to do the sum from r equals 1 to 40 of r squared minus 1, and then we're going to subtract the bit that we don't want. And the bit we don't want is the bit from r equals 1 to 9. So once we've done that, again, we can use the general formula. So we're going to have the sum from r equals 1 to 40 of r squared minus the sum from r equals 1 to 40 of 1, and then we're going to subtract the sum from r equals 1 to 9 of r squared, and then a minus and a minus, so we're going to add on the sum from r equals 1 to 9 of 1. So we're going to end up with 40 times 41 times 81 all over 6. I'm going to subtract this part here now. 9 times 10 times 19 over 6. And then we're going to subtract 40 and add 9. So that is 21,824. Okay, thanks for watching. The next video is 1.5, and that is the method of differences for summing series.